Okay, grade 12, let's have a look at some more complicated examples. Now, what I'm going to do is I'm going to give you a cyclic quad, A, B, C, D. There it is, a cyclic quad, and you need to prove that AE over CE is AD over BC. Now, the problem with this is we don't have triangles, so we need to locate them. I suspect that it's triangle BEC and the big one ADE. I'm not too sure about that, but let's have a look and see what we can do. Okay, now, the strategy that I'm going to use is actually quite a brilliant little one. What you do is you start off with what you've got to prove. You've got to prove that AE over CE is equal to AD over BC. That is what you want to prove. Okay, there it is. Now, the way I get triangles is as follows. I start off by saying, look, why don't we go take the letters from the top and the bottom. Okay, now if you look at this, we've got A, C, and I go in alphabetical order, A, C, E, and I'm not going to repeat that. Then I go A to B, C, D. Now I want to see if these guys are triangles. Well, A, B, C, D is most definitely not a triangle. A, C, E could be if you construct, so it's not nice. So those are not nice. It's not a nice triangle. Okay, so essentially, because of this, that breaks down. We're not going to even worry. But what you could do, that doesn't give you triangles. But if you go the other way, now watch this. AE over CE is AD over BC. What I do, and this is quite interesting, I'll take the letters from across. Okay, now look at this. Let's go in alphabetical order. AD. Is that a triangle ADE? Let's have a look here. ADE, yes, that is a triangle. It's the big one. And what about, let's go B, C, and E. Is that a triangle BCE? Yes, it's that little one there. Okay, now that's great. So that is a triangle. Now, once you've got two triangles, you can then start to see if the angles are equal. Now, let's have a look. Here's ADE. So let's write down A, D, and E in alphabetical order. That's that triangle there, and triangle BCE. So we'll write B, C, and E there. Now let's look at the diagram. ADE is fine. Then you've got B2, C2, and E. You always look and see which angle applies. Now B2 is in that triangle BEC, and C2 is there. So you know which angle you're referring to. Now what we've got to do is we've got to prove that certain angles are equal. Well, let's see. Angle A is C2. What's the reason for that? Angle A is C2. It's the cyclic quad. Okay. Then we've got, if you look at this, B2 here is angle D. So B2, if you think about it carefully, B2 is D. And then also E is equal to E. That's common. So we've got the cyclic quad, the exterior angle of a cyclic quad here. Okay, so now we can actually set out proving it. But now watch what I do. This is so important. I'm going to get my order of angles right. I'm going to say, if you look at that, in triangle ADE and triangle, now look at this, ADE, who goes with that A? It's C2, so it's going to be, the first one will be a C there. Okay, who goes with D is going to be B2, so D goes with B. Okay, and then we've got the remaining E there, just simply goes with E there, so that will be C, B, and E. So it's very important to get the order right. That angle equals that one equals that, and E is E. Now, if we set this out, what's quite fun is we can immediately see that angle E is equal to angle E common. A good way to start. A nice, easy pair of angles here. E is equal to E common. So that sorts out the first one. And then B, we can say that angle A is C2, and that's the exterior angle of a cyclic quad. Okay, there we go. So why is A equal to C2? A is equal to C2, exterior angle of a cyclic quad. And then we can say, in the next one, we can say D is equal to B2, and again, exterior angle of a cyclic quad. Good, now let's check that. D is B2. There we go, D is B2. Now at that stage, of course, we've now in a position to say, therefore, triangle ADE is similar to triangle CBE, 3 pairs of equal angles. Okay, and let's do the frog face now. We've got AD over CB is equal to DE over BE, DE over BE is equal to AE over CE, AE over CE, all from the similar triangles. But now let's have a look at what we've got to prove. We have to prove that AE over CE is AD over BC there. Okay, so let's copy that thing and bring him down, and let's have a look here. There he goes. Okay, so let's put him over here. Now we've got to use this to prove that. Well, pretty easy. Let's go and have a look. AE, does it appear anywhere? There. CE is there, AD is here, and BC is there. Now if you take those out, what a pleasure. You've got AD over BC is equal to AE over CE. And look at that. It's exactly the same as what you want. So you can just say, swap those around. You can say AE over ECE is equal to AD over BC. And there you've got it there. There was no need to even worry about cross multiplying, etc. there. Okay, well guys, this is so important, this stuff, that you get this in mind. Remember to identify your triangles by either taking the letters from the top and the bottom, or going across, and sooner or later you get a triangle. Once you've got the two triangles, it's very, very important that you make the angles. In other words, you write them down in alphabetical order. Triangle ADE, and what's the other triangle is BCE, and then you match. A is C2 because of the exterior angle of a cyclic quad. D is B2 for the same reason. E is common. And then you connect it. ADE, then it's CBE. You must make sure that that order is correct. Okay. And there it is, guys. That's the proof of that of the similarity theorem, where you are not given triangles and have to locate them yourself.